Hello everyone. So in this segment we are still in our chapter 4. In chapter 4 we are talking about integer number. So we are going to be done very soon, but before we finish our chapter 4 we want to talk about more about GCD, prime number, and one more new topics, LCM. Okay. So few things actually we already know about prime number and GCD. Just I want to wrap up with some more theory and some more knowledge, like from number theory. So if we have two numbers, maybe both numbers they are not prime numbers, but two non-zero numbers, they are said to be relatively prime if the GCD is 1. So what does that mean is that two non-zero number, they are relatively prime if they do not have any common factor other than 1. Okay, there is no other common factor. All right, there is no other common divisor or common factor that divides both this number, okay, other than 1. So the largest common divisor that divides both of this number is 1. Okay, say for example these two numbers are actually, they are relatively prime. And how I can prove that? Actually I can prove that by finding the GCD. Okay, so I'm going to show you how to find the GCD. Okay, and here I'm going to use the Euclid algorithm. Okay, Euclid algorithm to find the GCD. So for these two numbers, actually this is going to be there is going to be a lot of steps. All right, but mostly what actually we are going to do, we are going to prove that GCD of 17369 and 5472 equals to 1. So if we can prove that GCD of these two numbers is 1, then these two numbers are said to be relatively prime. Alright, so I'm going to be back in this example, and before that, if you are interested, actually you can give it a try. Alright, in that case, please pause the video and give these two numbers a try and find the GCD of these two numbers, and let's see whether GCD is 1 or not. So I'll be back in this example, but before that I just want to talk about some more topics. All right, and I want to see some more examples. So we're talking about GCD. Now we're going to see one more theory about GCD. So this is about like the GCD of two integer number a and b. Okay, we can represent the GCD of two integer number a and b as an integral linear equation of a and b. So what does that mean is that if we want to find GCD of a and b, okay, we can represent this GCD function, okay, of a and b as a integral linear combination of a and b, okay, something like that. So GCD of a and b equals to, I can represent that as a like that, ma plus nb, where both m and n are going to be integer number. All right, m and n can be both they both can be positive or negative integer number, but here we can represent GCD of a and b as an integral linear combination of a and b. Okay, so ma plus nb, where m and n both are integer number. So let's see one example. All right, how I can represent GCD of two integer number as a linear combination of that integer number. Okay, and here also I'm going to use the Euclid algorithm. All right, so just stay with me. There are also like, it's also like a lot of math, and mostly actually high school math, like plus and minus. But you know, like when we are dealing with a lot of plus and minus, always there is a chance that we miss some number, we miss some sign, and always there is a sign to do some mistake. Okay, so All right, so here actually first we are going to find the GCD using Euclid algorithm, and then we are going to go again in the backward step to find the linear combination of this GCD of A and B. Okay, so before that I'm going to use one example to find the GCD of two numbers using Euclid algorithm. Okay, and that will also give us another practice to use the Euclid algorithm. So let's say I want to find the GCD of two number 270 and 192. So in this algorithm or in this process, my A is 270 and B is 192, and I want to find the GCD of these two numbers. All right, so if you don't remember the Euclid algorithm, that means in that case actually I just want to remind you, the GCD of A and B is actually same as GCD of B and R. All right, what does that mean is that here we have A and B, and we have B and R, and A here we can represent A as a BQ plus R. Q is the quotient and R is the remainder. Okay, all right, and now in all of this example we are going to assume that the first number is greater than the second number, A greater than B. Okay, all right, now here we have GCD 270 and 192, so that's our A, that's our B, and I'm going to represent A as a BQ plus R. Okay, so I'm going to represent 270 as a BQ plus R. So here B is 192 plus something times something plus something. Okay, so that's my Q and that's my R. All right, and that would be actually 1. Okay, and R would be 78. All right, so what does that mean is that this GCD 270 192 is same as GCD B and R 78. Okay, now I have to find out the GCD of 192 and 78, and I can implement the same Euclid algorithm, right? So in that case my A is 192 and B is 78. Okay, so let's find out now. Let's represent A as a BQ plus R. So in that case B is 72 plus something plus something. Okay, I'm sorry, I'm saying 72, so sorry, that's actually 78. I don't know, I'm writing 78 but I am reading 72, I'm sorry. So 192 is going to be 78 times something plus something. Okay, so it will be actually 78 times 2 plus 36. Okay, all right, so now that's my Q and that's my R. Okay, so what does that mean is that GCD of 192 and 78 is same as GCD of 78 and 36, which is my R. Okay, so all right, so that means now I have to find out what is the GCD of 78 and 36. Okay, I don't know yet. I want to use the same Euclid algorithm. Okay, now how I can find that? Let's consider it as A, consider it as a B. Okay, so now I can represent 78 as like 36 times something plus something. Okay, so now I think that's something like more easier. 36 times 2, that will give me 72, and that will be 6. Okay, all right, now what does that mean is that this GCD value is same as GCD of 36 and 6. Okay, so again consider that as a and as a B. So I can represent 36 as like 6 times something plus something. Okay, so here 6 times it is going to be 36, and remainder will be 0. All right, now one way to do that, actually I can stop here. Okay, when remainder is 0, I can stop when I find remainder is 0. Okay, and I will know that my GCD will be the remainder from the last step. Okay, that will be 6. Okay, or I can go actually one more step. Okay, so that's actually I prefer most. I can go actually one more step where I can see that GCD of 36 6 is same as GCD of 6 comma. Okay, and here I have to find out how I can represent 6 as like, okay, so here I don't need to convert 6 to something, but this is same as writing B and R 0. Okay, and what we know from GCD is that if we find anything like that, GCD A0 is same as A. All right, so GCD of any number and 0 is the same number. Okay, think about that. GCD of 20 or any number 1920. Okay, so the common divisor between between any number and 0 is the same number. All right, so here I can just say that when I will find something like that, GCD of some number and 0, I can just say that this is same as the number B. Okay, I mean here it is actually A and this is B. When B equals to 0, I can say that GCD equals to A. Okay, so GCD of A comma 0 equals to A. So 6 is my GCD. And from here actually where I can stop, like from this transformation, when I transform A equals to BQ plus R. All right, so whenever I will find R equals to 0, then actually I can stop. I can look at my last step. Okay, where I have my A equals to BQ plus R. Okay, in my last step the R value is actually the GCD. Okay, all right, so that's just one more example how I can calculate the GCD using Euclid algorithm. Okay, so my preferred version is to go all the steps until I find the GCD of something comma 0. Okay, something comma 0, then the GCD of something comma 0 equals to the same number, the something number A. Okay, so GCD of A and 0 is A. I'm going to use that. Now I'm going to use the same Euclid algorithm, and using the same concept I'm going to find the GCD of two number as a linear integral combination of these two number. Okay, that means the GCD of these two number was 270 and 192 is 6. I'm going to represent 6 as a m times A. All right, 270 plus n times 192. Okay, and our theory is saying that every GCD of two integer number A and B is an integral linear combination of these two number A and B. And now we are going to see how we are going to find the value of m and n. Okay, and we are going to use the same Euclid algorithm. All right, and I'm going to show you in the next slide. So hello everyone. So here actually this is the whole step actually we did in our last slide to find the GCD of two numbers 270 and 192. Okay, so these are the all steps, and these are the all, actually you can see these are all are actually transformation of A as a BQ plus R. Okay, so as we said that when we will find that r equals to 0, okay, here actually we can stop, and we will know that in our last step, then in our last step the remainder r is our GCD. Okay, so from here we can say we can actually say that this value 6 is our GCD. Okay, so this value 6 is our GCD of 270 and 192. All right, now we are going to actually start from here. All right, and we are going to use all of this transformation. All right, and we are going to find out the integral linear combination of a and b. All right, so let's start from here, means let's start from this equation. Okay, so from that transformation, actually what we can say. Okay, so let's just rewrite this here. So we are going to start from this line. Okay, so we have here 78 equals to 36 times 2 plus 6. Okay, and we know that 6 is our GCD. Okay, now we are going to write down that what the value of 6 we can write it as like 78 minus 36 times 2. Okay, so that's our GCD of I'm sorry, let me actually erase that. Okay, all right, so this value is actually our GCD of 270 and 192. Okay, like our left hand side. Okay, I'm sorry, so this one is our left hand side. Okay, so we are going to represent this value 6 as a linear combination of m times a plus n times b. All right, so let's see how we can do that. So from this line we can say that 6 equals to 78 minus 36 times 2. Now I'm not going to actually verify all of them. I know that from this equation this is true, and you can see that actually 78 minus 72 is 6. Okay, so that's fine, but I'm going to actually look at that how many 270 I can find here and how many 192 I can find it here. Okay, all right, so now from that I'm going to use the equation, this one. Okay, so what is the value of now 36? Okay, here I have 178 and here I have minus 236. Okay, that's how actually I'm going to visualize that. Okay, now how I can actually represent 36 here? So I'm going to use this equation, and from this equation I can write as like 36 equals to, okay, 1 times 192 minus 2 times 78. Okay, means 36 is as a combination of 192 and minus 278. Okay, so here actually now I'm going to write it like that. Okay, so that means 6 is like 178 and minus 236. So let me write down it like that. Okay, now I'm going to write down the value. I'm going to replace 36 using this equation. Okay, so remember I'm not going to actually do any calculation like any multiplication and plus. Okay, all I need to find out how many 270 I have here and how many 192 I'm going to find it here. Okay, so instead of 36 I'm going to replace the value of 36 like that. So 1 times 192, okay, minus 2 times 78. All right, so again remember, like I'm not going to do any multiplication and any plus minus here. All I'm going to find out actually how many 78 I have here, how many 192 I have here. Okay, so here I have 178 and here I have actually 2 minus 2 and minus 2, 478. Okay, so that should give me total 5 times 78. All right, and minus 2 times 192. Okay, so that means I have 578 here and I have 192. I have minus 2, 192 here. Okay, now let's go back to the last one. So how I can replace 78 here? So 78 I can replace it like that. Say 1 270 minus 1 192. Okay, so let's write it here. 5 times, so 1 times 270, okay, minus 1 times 192, okay, and 2 times 192. I think now you can understand how actually I am going to find out my right hand side. Okay, so here I have to just calculate how many 272 I am going to find it here and how many 192. Okay, so overall I think I am going to find out like 5 272, 5 times 1, okay, 270. I'm saying 272, so it's actually 270. Okay, 5 times 270. All right, and here I'm going to have minus 5 and here I have minus 2, so that will give me minus 7 times 192. Okay, so that's actually like m times 270. Okay, so plus n times 192. Okay, where we have m equals to 5, all right, and n equals to minus 7. All right, so and that's our right hand side. Okay, and that's how I can find value of m and n. So GCD of 270 and 192, I can represent that as like 270m plus 192n, where m equals to 5 and n equals to minus 7. Okay, and let's see, and you can actually like verify that. Okay, 5 times 270 plus like minus 7 times 192 should give you the value 6. Okay, and that's how you will know that you are on the right track. All right, so we'll be back in our next video.